Hey guys, welcome to 2.2 Basic Differentiation Rules. In this lesson, I'm going to show you guys how to take the derivatives of terms of higher degree much more quicker than using a definition of derivative. But before we do that, I want to give you guys a quick review about rational powers. So, you guys have seen in pre-cal that the square root of x is the same thing as x to the 1/2. So, why is that possible? Well, when we square something, we usually denote it with a little 2 on the top. If you want to square root something, it's the opposite operation as squaring, and we usually denote that by square root of x, but we can also denote it by the reciprocal of 2, which is the 1/2. So x to the half means the square root. Similarly, when we take the cubic root of a number or of a function, we can also express that as x to the 1/3. We could even do the fourth root, and that is the same thing as x to the 1/4. It doesn't matter what number. You can take the nth root, and that is the same thing as 1 over x to the 1 over n power. Another thing that you guys have seen last year also is the negative powers. Anytime you guys saw a negative power, you guys took the reciprocal of the term that it affects, and then you just left it as a positive exponent in the denominator. So for example, x to the negative first, I'm going to reciprocate the term and then write it as 1 over x to the first as a positive exponent, but really that's just 1 over x. So a negative exponent didn't really yield a negative answer. It just told us to take the reciprocal and then keep the power but as a positive in the denominator. Let me give you another example. X to the negative second. X to the negative second. The negative 2 affects the x, so that means I'm going to reciprocate the x and keep the 2 in the bottom, and I'm done. One more example before we move on. I'm going to give you guys 4x to the negative fourth. Well, negative 4 is affecting which term? The 4 or the x? It's only affecting the x, so I'm going to reciprocate the x, leave it as 4 positive, but notice that the 4 wasn't affected by the power, so we leave it as a numerator. And that is how you convert these negative exponents into fractions. Or vice versa. You could do it the other way around. Now let me go ahead and talk about the derivative rules that we're going to be discussing today. So there's a shortcut to find the derivative of functions. And one of the shortcuts is the power rule. The power rule says that anytime I want to take the derivative, this d dx means the derivative with respect to x, of a term of a x raised to the nth power, where n can be any positive integer, where n can be greater than or equal to 1. Okay? The derivative rule says that we drop the n as a coefficient and we take 1 away from the power and we're done. Let me rewrite this. The derivative of x to the n is n x to the n minus 1. That's it. Okay, let's look at the first example. First example says find the derivative. So my function is x to the third. If I take the derivative of x to the third, that I just drop the 3 as a constant, keep the x, take 1 away from the power, and it's 3x squared. It's that easy. And it even possesses the same pattern that we had seen. You took the derivative of cubic and it gave us a quadratic, and there it is. You could even use the long definition to even prove to yourself that it's just 3x squared, but I'm pretty sure you guys believe me right now. Letter B, x to the square root of x can be rewritten as x to the half. So it doesn't matter if it's a fraction or not, we're still going to use the power rule. Okay? So and really I think I messed up on this part over here. Do you see that n is greater than 1? Well, it can work for fractions as well. So that's my fault right there. So it can work for any number n. It doesn't matter what it is. So disregard the statement that I had said a while back. So the power rule works for anything with a power. It could be 1, it could be a half, it could be -1, it could be a negative half, it doesn't matter, but it will not work for 0. So that's just one thing that you guys have to keep in mind, that n cannot be 0. So now that I fixed my mistake, let's go ahead and use the power rule. X to the half, the derivative of x to the half is 1/2 x, and then to the -1/2 because I took 1 away from the half. Well, we all know what a negative power means, right? It just means the reciprocal. 1/2, 1 over x to the half. And even further, I can leave it as 1/2 square root of x, since x to the half is the same thing as square root of x. Example number C, letter C. This can be rewritten as t to the -4. I'm going backwards now. The reason why I want to go backwards is because I can use the power rule much more easier. Same rule applies. Drop the negative power, keep the t, take 1 away from the power, and that will give us a -5. Example letter D. We have 5. What's the derivative of a number without an x? Well, let's graph it, and just to make sure we understand this, if I draw the line y equals 5, it's just a horizontal line crossing at 5. What is the rise and what is the run? What is the slope of a horizontal line? 0. There's no change. And we all know what a derivative means. A derivative means slope. So what's the slope of the function 5? The slope of the 5 is 0. In other words, the derivative of a constant. It doesn't matter what number it is. Any number, the derivative of a number is just 0. Letter E. This time we have a number in front of the x cube. No matter, we're still going to use the power rule. Keep the 5 in the front, drop the power 3, keep the x, and then take 1 away from that power, and my derivative is 15x squared. So here's some other rules that you guys should know, but eventually you guys would just know this by heart. So the derivative of a constant, oops, I'm pressing the wrong button. The derivative of a constant is just 0. We had mentioned that in part D. Any number, it doesn't matter what it is. A constant is any number with no x. And then we have the constant multiple rule, which mimics part E. The constant multiple rule says if I have a c times x to the n, the derivative of c x to the n can be the same thing as c times the derivative of x to the n, which is just c n x to the n minus 1. The next thing I want to talk about is the sums and difference rule. The sums and difference rule, it just says that if you have more than one term, if you want to take the derivative of more than one term, you simply just take the derivative of each term. So rewriting this rule, I can say d dx of f of x plus the derivative of g of x. Just distribute the derivative, that's all it means. Similarly for the minus one, the derivative of f minus the derivative of g. And that's it, I'm done. Now, for the next example, we're going to use the sum and difference rule. Now, notice that this example right here has a difference and sums involved. So it doesn't matter what we do. If we want to take the derivative of this function, of this polynomial, we simply just take the derivative of each term. So what's the derivative of 4x cubed? It's 12x squared. Minus, what's the derivative of 5x to the second? 10x. What's the derivative of 7x? 7. What's the derivative of a constant? Well, that's just 0, and that is my derivative. One more example before I end this video and go to the next part. Here I have a rational function. I have a function on the top over a function on the bottom, but the function on the bottom is a simple x. I can rewrite that as 5x to the 5th over x minus 3x to the 4th over x plus 4 over x. Now, I can simplify now since I have common factors top and bottom. Oh, I'm sorry, 4 over x. I can simplify this, so it's 5x to the 4th minus 3x squared, to the third, and then plus 4x to the negative first. Because my x is in the bottom, I can move it up to the top as a negative power. Now I can take the derivative of all these three terms. The derivative of 5x to the fourth is 20x squared, to the third, The derivative of negative 3x cubed is 9x squared. And the derivative of 4x to the negative first is a negative 4x to the negative 2. One thing about negative powers, anytime you take the derivative of a function that contains a negative power, the negative will change the sign of whatever this number is. So if it's positive, it'll become negative. If it's negative, it'll become positive. So I'll see you guys in the next video for the second part of this worksheet.